Good morning, all. I welcome you on the day three of National Workshop on training and practices in computational chemistry. Today, we have a distinguished speaker with us, Dr. Koushik Mondal. Uh, he is also associated with ACM, Association for Computing Machinery, Society for Advanced Computing as a Science and Profession. So we have a session on Python R programming with him. And I would like to briefly introduce Dr. Koushik Mondal to all of you. Dr. Mondal did his bachelor's in mathematics from Calcutta University in year 2002. He afterwards completed his master's of computer applications from the West Bengal University of Technology in the year 2006 and further pursued the Doctor of Philosophy from Vishwa Bharati University Shanti Niketan in 2013 respectively. Uh, he, he has served in the capacity of research personnel, a project funded by TQ, Government of India in the Department of Computer Science and Engineering, Kalyani Government Engineering College. He is now serving as a principal system engineer in IIT ISM Dhanbad, where he is presently handling IT and ITES project of rates 40 crores. I repeat, rates 40 crores. Prior to this, he served IIT Indore, ISER Pune, and ISC Bangalore in different capacities. He has published about 30 research papers in various journals, book chapters, conference proceedings, both international and national repute. Dr. Mondal won prestigious gold medal in Best Students Project Award from Tata Consultancy Services for his outstanding contribution in project development in 2007. He is presently guiding two PhD students and he has served as an IR DPO technical head in conducting advanced JEE, GATE, JAM examination successfully. Dr. Mondal received the Best Paper Award sponsored by Spinger in India 2016. He served in different editorial board as a reviewer, PC and TPC member like IEEE, SMC, JPRR, IJACI, etc. He is a lifetime member of CSI, ISCA, SSI, ACCS, IACS, IT, IAE, NG, member of IETE, CSTA, SIAM, and senior member of IEEE, SEM. Recently, Dr. Mondal nominated as AWS Faculty Ambassador by Amazon Web Services, Amazon Inc., and received a prestigious appointment as Distinguished Speaker of ACM DSP for the 3 years. With this brief introduction, I would like to request Dr. Koushik Mondal, who has accepted our request for delivering the key session in this workshop on Python programming, Python R programming. So over to you, sir.
Thank you, Anurag. Good morning to all of you. I hope you are getting my voice clear, right?
Yes, sir.
Yeah. So I am just from the computer science background, so it is maybe creating some nuisance in front of you that what I am doing with the computational chemistry people. But now it is research, this is going on hands to hand. So we have to do everything with the computational guys. So I am here, I am going to introduce one new language to you. I hope you are not aware about R, right? So that's why I have choose my today's topic, data mining and data analysis application in R for all of you. So basically we are going to introduce this particular language to all of you, and then subsequently I will show you how you get into it. So what are the packages that you can use for developing your R skill, and subsequently what are the chemistry, computational chemistry related packages that are available in R, so that you can start your work in R language, right? So this is very difficult to introduce one programming language through e-workshop, but still I am trying my level best. I hope you will enjoy the session, right? So before starting, this talk actually yeah. So this talk actually brings you from through ACM Distinguished Speaker Program. Under ACM Distinguished Speaker Program, I am delivering this lecture. As you know, ACM, the Association for Computing Machinery, they are the premier global community of computing professionals. And we have our dedicated mission and vision. I am proud that I am a senior member of ACM. So this distinguished speaker program is made possible because of the ACM. So they endorse my this particular program. So that's why I am here with you. You will get additional information about ACM in the dsp.acm.org, right? So already Anurag told about me, but this is the brief introduction. I am just presently serving in IIT ISM Dhanbad. So already I have served these all these organizations. So more about me, you will get my IIT ISM web page, my Facebook page, Twitter, LinkedIn, everywhere, right? So before starting, this is too interesting thing. So if we knew what it was we are doing, it would not be called research, right? So that's it. So every day we have to gaining some knowledge, and then we are planning it, implementing it in our research domain to develop something new. So when we start our research, that time we don't know what we are going to do, but we have a rough sketch in our mind. Slowly we put everything over years, and then we will create our PhD, right? So this is from Albert Einstein, and next one is Alan Turing. I hope you know about Alan Turing. So a computer would deserve to be called intelligent if it would deceive a human into believing that it was human, right? This is the very beginning test kind of thing, Turing test. I hope you have heard about it. So this is Alan Turing. So today's outline of my talk is why this AI, right? So nowadays people talking about computational chemistry because we have uh, computational power with us. Earlier that is not there. We have the AI model with us. We have the machine learning model with us that is going to help us, right? So that means evolution is in the air. And we have the basic statistics that we are doing in pen and paper, say, or we are writing a long code for one statistical model. Nowadays, because of this kind of Python or such kind of high level languages, so we have that statistics for algorithmic business is easy for us, right? So we have the programming language for ML. So I will discuss about basics of R, statistical distribution in R, hypothesis testing in R, data mining, data manipulation, how we will do it, why we are planning to use R, what you will get from there, the data type and data object, how you are going to do the subsetting thing, what are the important utilities available in R, and reading and writing external data, because nowadays everything is an external data, right? So even I will show you how you will fetch data from your PubChem directory, right? Repository. Because chemistry people, they are using PubMed or PubChem repository for their data set, right? So how you will bring those data set in our environment and you can manipulate it. So, and you can use the statistical or machine learning algorithm in R so that it is easy for you all to do all such kind of manipulations. I am going to talk about basic graphics and two interesting packages that are available inside R. So there one is Swirl, another one is Rattle. And then we will discuss I will discuss about computational chemistry packages. Those are available in R, right? So let us start. So why we are talking about this computational chemistry, everything? So the fundamental thing is that nowadays everything, this is AI driven, right? So everything is AI. We are talking about, so even why means you want to park your car, you want to choose the bag you have seen with your fellow friends. So movie, whatever you are planning to do, everything. This is actually touching our life, right? So you know that your grandparents, they may not be conversant with the English language. You just speak in your language. That is also possible. It is automatically translated. Natural language processing is there. So bridging the language barrier. So predicting sick babies' vitals, and even the enabling the blind to see their surroundings. Right? Wow, what kind of things is right now going on with the AI industry, right? So everywhere you think about, so nowadays, so during this COVID pandemic, so everywhere people are talking about, in a hotel, in a hospital, say during your introduction, so robot is doing on behalf of some human being, right? So they are taking your basic details, and then they are allowing you what to do next, right? This is great. So now everywhere, this is AI for public good, right? So in our consumer services, AI as a services, transforming in industries or analytics. So we are going to focusing on this part, analytics, right? How we are going to use some computational or machine learning languages, say R, for the analytics purpose. And that is in the chemistry domain, computational chemistry domain, right? That is our main aim. So great till now. Okay, so fact is that, so now we have that if we compare it with 2014 to 2016, every industry, they are actually moving with AI, right? So there is a huge talent shortage, right? Still people are trying to cope up with the environment, right? So this is the revolution in our thought process, right? 1960s, 50s, that time we are talking about artificial intelligence. Then slowly it becomes machine learning. Then we are concising our thought process in deep learning kind of thing, where we don't need any machine learning model, means we have the input, and that input will decide what kind of model it will fit in, and then accordingly it will give you the output. It will give you the output, right? So this is the main thing. We have the big data available. Why this is? Because evolution in computing, right? So we have the big data with us. We have the new ML technique with us. We have the GPU acceleration with us, right? So with the help of those, it is possible for us to do some kind of good computing thing in our domain, right? So evolution in computing, right? So why evolution in computing? Because the stack evolution in the background happened in computing. So if you compare with the stack evolution in the computing, we have in 2018 onwards, TensorFlow kind of thing, Apache Spark kind of thing. I know these are not, you are not accustomed with all those terms maybe, because if you are from the chemistry background, but the computing thing, why people are now working everything in the computational chemistry, people are relying on GPU architecture, because in background, in the backbone, we have the TensorFlow, we have the Apache Spark, right? So we are planning to deal with the last set of data chunk, right? So evolution drive innovations, right? So we have innovative idea everywhere. If you think about image or video classification, if you think about drug discovery, cancer cell detection, everywhere, video capturing, video surveillance, face recognition. So we have that evolution. So we have the innovation in hand, right? Because of this evolution. So now innovation delivers answer, right? So we have the inputs with us, either this is in the form of text data or image or video or audio. So we have the business question, and AI and ML or DL, they are doing this either detection or classification or segmentation or prediction or recommendation, or even if required natural language processing, right? So they are doing all such kind of things, and they are offering us the targeted output that we actually want, right? So now this is 2018, the momentum from 2018 to 20, the startup AI momentum is like this. So in 2018, we have AI startups around 3,000, but by 2020, almost end of 2020, so now we have 85% of all our customer service interaction will be powered by AI bot. That is there. So nowadays, if you call in any help center, means call center, so this is generally the bot who is interacting with you with your basic details. After that, they are forwarding your call to the particular targeted people so that they can offer you the solution in a minute or two, right? So this is the path of the digital business that is going on. So earlier people always talking about, so nowadays this is everything algorithmic business. Earlier people talking about mobile business, right? Everything based on mobile. From there, we have achieved the digital business. But now we are talking about algorithmic business. What kind of algorithm is working behind to get the solution? That is our main aim nowadays, right? So that is cognitive computing, machine learning, IoT, predictive analytics, everything is in place. And now we are working on all these domains, right? So this is actually the statistics for algorithmic business. Though we are moving ahead, so the basic statistics that is required, the computational thing that is required, that is very much that is very much required even today, right? So even if you have the computational thing and you have your DL, you have your ML algorithm with you, still you should know the basic traditional research or related statistics that are required for your designing, right? For your problem designing or solution, for getting the solution, right? So this is the combination of all those fields. So if you want to design your model, so then you have to know all those things in a suitable manner, right? So why we are talking about R? You may think about that in chemistry, there are so many software available with us. So why should we will choose R? The basic fundamental thing when people talking about R, actually, Guho 2006, back in 2006, he developed one model in chemistry. That time, actually, when people thinking about that, we should have one environment where people can access the thing in a free mode, right? So free software environment, that is the main idea behind this, developing these particular all chemistry related packages developed in R in nowadays. That is the main thing, is that if you have the say ChemDraw, if you have Origin 9, so you have MATLAB, you have Mathematica. So these are all paid software, right? So if you want to do the same thing in a free software environment, then you need some good software, right? The basic of R, basics that is so based on statistics, right? So all the statistical model that is available inside R. So R is a free software environment for statistical computing, data manipulation, charting, and widely used in the scientific world, right? So this is a high-level interpreted programming language. So being high-level language, no need to write means in number of lines, right? So you know that what is your target, and you should know which particular package you are going to use to achieve your target, right? So this is the case that nowadays so many packages available. If you know what exactly you want from that particular from this programming environment, you need to install or you need to fetch the library from the software domain repository, software repository, and then you just install it and you just work on it, right? That's all. So R is the successor of the S, and created in 1992. So this is the Robert Gentleman and Ross Ika. This is the University of Auckland They are actually developed it. And now we have the dedicated R development code team, right? They are managing it. So why we are planning to use R? Because this is complete statistical environment, efficient function and data structure for data analysis, powerful graphics. I will show you that with few lines of code, how you will get the good graphics in our environment, right? Because ultimately you have to present your research work in a good graphics, right? So unless otherwise it is difficult for you. You know that a picture always this is telling that 1,000 of words, right? So that powerful graphics facility available here. So access to fast growing number of analysis package, as I told you, most widely used language in bioinformatics and also computational domain, computational chemistry domain. So standard for data mining and biostatistical analysis, technical advantages, this is free, open source and available for all OSs, right? Be it Linux, be it Windows, Ubuntu, Mac, no issue, right? So the repository is available in CRAN, right? You just Google it, CRAN. The full form of CRAN is Comprehensive R Archive Network. So this is the R project code team, they are maintaining it. So if you installed it, then from there you have to download it, R, and the GUI interface, that is RStudio. RStudio is available, that is also free. You just download it and then you just it will automatically integrate your R in your RStudio, right? No need to set path or anything. Okay, so this is the fact actually. So people if you ask any researcher, they generally less heard about R, right? So this is so new, not so new, but people are not still working in this particular platform. So why we are using R? Because of the tools available with us. So earlier the number of analytical packages available, right, like this, and now while you are planning to using R, you have n number of packages, right? N number of tools with you, right? That's why we are planning to use R, right? So if you check it out, R is there. So primary tool, people using as a secondary tool, and occasional use. So everywhere you check it out. So with Statistica, Mathematica, Minitab, SAS, everywhere R is prevailing. So now these people are using R just like anything, right? So even Weka, SAS, Microsoft SQL Server, data mining function, so they are not using for that, right? Because and most of them, these are paid software, right? So that's why we are using R. So these are the things why we learn R. I have already discussed, right? Just look into it. So now, if you write this particular command, the dimension available dot packages in our environment, you will get 3,700 community package, and this is growing exponentially, right? So nowadays people are only for the chemistry, you don't believe around 1,000 packages are available. More than 1,000 packages are available, right? So in our environment, right? So community is developing, so growing so fast. So you will get anything, you just tell me, you will get some packages to solve that particular problem, right? So this is the environment. First I will complete the PPT, then I will show the environment, right? So then I will show you how to do it, practical thing. And most of the thing I have put it inside the PPT so that those who don't have computer right now, they can just perform it or execute those programs at home in your leisure time, right? And I will share these all PPTs and also the script file with you all. Okay. So this is the actually our GUI OSX version, and this is the command line version. If you type just R, you will get this R version. Look here, I have typed Give me just yeah, annotate, right? Yes. So this is, I have already used R here, right? So then you will get the R version in your machine. I am using presently 3.6.3 version, right? And this is the GUI version that is also available with us, right? So if you open means IDE for R, so integrated development environment studio, so you will get these four things, right? So you have the editor panel on the left top corner, and then you have the console panel, you have the plots panel, even you have the files, plots, packages, and help and viewer panels in the means fourth quadrant, and you have the workspace panel in the top right corner, right? So these are the four panel available in the RStudio IDE. So packages repository, if you have you are planning to use pure R related thing, so then you have the CRAN package repository. So this is more than 4,500, even bigger. So all general data analysis and data mining tools are there. So if your research is related to biology or chemical modeling, so you will get so many packages in bioconductor, right? So this is 700 packages. So now this is more than 1,000 packages available in bioconductor. Another one is a repository is there, Omega Heart, right? So this is the programming interface available. So how to install it? So this is just install R from your operating system, just cran.rproject.org and install RStudio from there, right? So if you want to install the CAN packages, this is the command that we generally use it, install.packages. If you have multiple packages, you just create this C, and then within that, you just put all package name. And if you have the package repository, you don't have the repository, you have downloaded it locally, then you have to bring that zip file into the environment with the help of install.packages, package.zip, and then repository is null, right? And you have the bioconductor packages, then this is the source to bring the bioconductor. These are the steps to bring the bioconductor packages. Nowadays, we have so many other commands available. I will show you how to bring bioconductor. Actually, BioC Manager is now available. If we install BioC Manager, from there we can fetch any package related to bioconductor, right? So if you are planning to starting your R environment, just type the R in the terminal, right? And if you, when you are planning to close it, just then just Q and first bracket, right? So it will ask you that whether you are going to save your workspace. If no, then you just press no. If yes, then it is good for you. Then next time when you are planning to open your R, that time you will get all the workspace related variable intact there, right? So numerical data, data types, the basic of any programming language, that data type, numerical data, complex data, character data, logical data, everything. This is available in R. Actually, what we will how to assign any variable means how to assign value to a variable. This is that arrow and then hyphen, right? So I am assigning 1, 2, 3 variables to X, right? Now, after the semicolon, I have typed X. That means I am trying to print the values of X. That is 1, 2, and 3. Now, I am planning to check whether this is a numeric value or not. So that for that function is available with us. This is is.numeric. So then you will get it that true. So as character X. So if we put it in any numeric data in a character data, then we have to it will transform it as dot character X. It will transform it double inverted comma any numeric value that is treated as a character, right? So character data, you will get it. So you can check it. If you want to change the character data to the numeric, that is also possible. complex data, that is also possible. And now logical data, right? So what I am asking that assign the value 1 to 10 and check it out. So what are the values available in X which is less than 5, right? So this is less than 5. That means 1, 2, 3, 4. Up to 4, this is true. And then 4 onwards, so this is only less than, that's why 4 onwards, everything rest of the things false, right? So not X, that is also available. Which X always return index for the true value in the logical vector, right? So that's why the logical vector, they are giving you 1, 2, 3, 4. Okay. So now vector and factors, these are the data object available with R. So I am creating one vector, and I am assigning value 1 to 10 to that, and then I am giving some name to my vector, that is my vector names to letter, right? Now I am planning to print it out. So now this is my vector 1 to 5. As I type, it is offering me A, B, C, D, E, and the value is 1, 2, 3, 4, 5. If you want to subsetting kind of thing, that is also possible. So that is there. And factor is this is 1D. So vector with grouping information. That means, so we want to do, we have the labeling with us. We have the say dog, cat, mouse. So actually this is the, they are labeling it, and they are treated is that all those things, this is 3 labels, right? So they are factorizing it to the 3 labels, that is cat, dog, and mouse, right? So matrix is always important. Everywhere we need to do that. Matrix and data frame, these 2 things, right? So matrix 2-dimensional structure with data of same type, and data frame 2-dimensional structure with variable data type. This is the main difference between that. So I am creating one matrix. So this is my mat. This is matrix 1 to 30. This is the, I am mentioning the number of rows, number of columns, and this is by row we have to put the data. So then we are asking that what is the class of the my mat that I have created, that is matrix in nature, right? So I am trying to fetch the data 1 to 2 first. So it is that fetching that data, right? So after the comma, I have not mentioned anything. That means it is taking everything, right? So data frame, I am creating one data frame, say my data frame, that is again data dot frame, column 1, 1 to 10, and column 2, 10 is to 1, means 10, 9, these all kind of things, right? So now I am trying to put it here as printing, trying to print the value. So my day 1 colon 2, and then I am getting all the values, right? So array data structure with 1, 2, or 3 more dimension, right? You know about array. So another, these things means data frame and list, these 2 are very interesting thing in R, right? So container kind of thing, list for any object type. Look, so I am creating my list. So I am writing that list, my name Ham, and wife's name Tum, number of children 3, child age, that is they are 3, 4, 7, 9, right? So I am asking the data. So I am trying to fetch the data. So I am just printing my L, my list, and it is showing that means dollar name, anything in from the list if you want to fetch. So if you only want to fetch a name, so my L dollar M name, that will give you only the answer Hum, right? So and subsequently you will get all the values here, right? So function, you can write your own function. So and then you can use it inside this R environment, right? So subsetting, I am trying to subset my thing, that is also available. Subsetting the same length of logical vector, that is also available. Field name, that is also available. And calling a single column or list component by its name with the dollar sign, right? So I am trying to fetch that particular Irish dataset. From the Irish dataset, I want only the species. So I am writing here. So Irish species, dollar species, and 1 to 8. So it will fetch the labels, right? So I am trying to combining two objects. So combining object with the help of C, right? So combining object C or C within the bracket, say 1, 2, 3. That means I am offering 1, 2, 3 values. So here I have not assigned to any variables. Now I am assigning X and Y. And if I want to combine it with the help of the X and Y C variable, I can combine it, right? The cbind and rbind function can be used to append columns and rows. Say you have one matrix, you want to add some rows in the matrix, right? You want to add some column in the matrix. How will you? So that's why this cbind and rbind function available with us. With the help of that, we can add it, right? Here, look, I have that ma variable. So there I have the X and Y. Now I am printing ma. And now I want to row bind it. So I just replicate the same thing. And now it is showing that value, right? So length and dimension, how you will get the length and dimension. So this is the length, this is the available function, available length function. And with that, this is our data set, Irish data set. And from there, I am picking up particularly the pieces field, right? That pieces field, this is 150 numbers pieces field are there. So dimension of the Irish data set, if I am asking that, so it is telling that 150 rows where 5 columns, right? So you can accessing row and columns name in the of 2D object with the help of row name function. That is also available. And we have the column name function. So if you want to return the name field of vector and list, so this is the way to return the name field of vector and list. Okay. So sorting the object, how you will sorting object in R. So this is the function available sort, right? So if you put it in the index, decreasing is equals to false or increasing is equals to false, accordingly you will get it, right? So sorting on multiple column, that is also possible with just one single line command, right? That is the beauty of the any high level language, you know. So no need to write means n number of lines of code for getting your answer. If you know the language, then this is just 1 or 2, 3 lines with you. That is sufficient for you to get the answer, right? So if you want to reading and writing external data, that is also, if you want to importing your data, that is also possible, right? So I am importing my data into the data frame. DF naming convention always crucial, right? So that's why I have put it DF. That means I am importing my Excel data in a data frame, right? So the delimiter is already separator is also mentioned here. This is tab. And if you know that if this is CSV, then separator is the comma, right? So CSV full form is comma separated value, right? So then we have the export data from R in the tabular files. That is also possible. You can copy and paste. So that is also there. So copy paste from R into the Excel or other programs. That is also possible, right? So now the basic graphics, as I told you that this is rich graphics. R is available means means R is having rich graphics, right? So that's why means people are very fond of R, especially for when they are means delivering their research related outputs, right? So means you will get the plot function, bar plot, box plot, histogram, pie, dot chart, image, heat map, everything and anything, right? So that is available. And if you don't know anything about that particular function or any particular packages, no need to go anywhere, not even in Google, right? So what you have to do in your RStudio, you have the help button in your fourth quadrant, right? So there you have to just type that particular function name or that particular package name, and it will give you everything about that package. That is the beauty of this R environment, right? So now this is the first example for all of you. Say I am planning to set my working directory, this is the chemistry talk, today's talk. So I have put it one folder. There I have put this data, and I am asking the number of males and number of females available and their height histogram I am planning to draw. So look, this is the beautiful thing. Look, this is the thing, you will get it in and with these 4-5 lines of code, right? So that is available, very much possible in R, right? So this is another connecting polygons if you want to do it. So that is also possible. Now you want for box plot, this is the box plot. So simple, right? So only 3 lines of code you will get such kind of box plot here. So look, this is also another output. I have not put the code here, but the thing is that diamond cutting kind of thing. So you will get it this kind of graphics with all details, all color, vivid color, means, and they are cutting what kind of, this is fair, good, very good, premium, ideal. So everything you can put it in this picture. Look, so this kind of graphics you can generate with the help of R, right? So now manipulating data. So as I told that, as this is a high level language, you will get all such kind of function like reshape, tidyr, data table, libraries, and ddplyr. So with the help of that, you can give it will offer you means advanced query and manipulating data structure. Means if you want for filtering, selecting, adding, ordering, aggregating, reshaping, combining, everything, right? Means these packages are one of the top most useful must-have packages in the analytics toolbox, right? So these are available in R and free of cost, right? So data manipulation with the help of data.table. This is a library providing a significant enhancement of the regular R data frame. So it allows you the user to perform really fast. That is in-memory processing, right? Nowadays, people are always talking about in-memory processing. That means no need to send your data back to the hard disk, right? You put it in your RAM and there you just process it, and there is no such kind of page fault kind of thing going to happen with your programming. That is the in-memory processing, right? So it covers the following tasks, as I told you. So for profiling the code, turning on the just-in-time compilation, vectorization calculation, algebraic computation, so everything, algorithmic differences, executing parallel computation in a cluster environment, that is also possible in R, right? Using the power of graphics card processor, CUDA OpenCL. I hope you have heard of OpenCL. So implement key parts of algorithm in C++ and call them in RCPP. Even if you have the code in C++, if you have the code in MATLAB, if you have the code in SAS, so you can incorporate those codes in our environment, right? So data manipulation with the help of F-table. Look, this kind of data means every time ministry asks such kind of data from us, right? So about your admission. So tell me about the department, tell me about the male, female, admitted, rejected, reason of rejection. So that you can easily draw it with the help of F-table command, right? So only one command is sufficient for you to draw such kind of conclusion, right? So that is the beauty of the R. That is the beauty of the high level language, right? So now statistical distribution with R. So you will get these means working with the different statistical distribution. We often want to make probabilistic statement based on the distribution, right? So we typically want to know one of the 4 things: the density, right, PDA at a particular value, the distribution, CDF at a particular value, the quantile value corresponding to a particular probability, or a random value from a particular distribution, right? So obvious, earlier we have all this information in the back of the book, right? we have the logbook. From there we have to take the value and then we have to calculate all those things, right? But now we have R with us, right? So just one command away with your data. If you have the data, so the general naming structure. So if dname calculates the density PDF at input X, right? Pname, that is calculate the distribution CDF at input X. Qname calculate the quantile at an input probability. And rname, that is generate the random draw from a particular distribution, right? So look, we have the random variable X. This is the normally distributed, say. So then we have the mu2 and the sigma square by S for 25. Now we are planning to get the calculate the value of the PDF at X equals to 3, right? So this is the simple command available with us. So that means X is equals to 3, mean 2, and we have the standard deviation is 5, right? So you will get the value of the D norm, right? So to calculate the value of the CDF, that is Px less than equals to 3. So this is the probability that X is less than or equal to 3. Use the P norm. So this is the function that is available. And we have the Q norm, we have the R norm. So the function exists for many other distribution. So any command related to binom, that is binomial. T means T distribution, Poise means Poisson, F means F distribution, chi-square means chi-square distribution, right? Where star can be anything, means either this is D or this is P or this is Q or this is R. 4 kind of distributions available with us, and we have the either binomial or we have the T distribution or we have the Poisson, we have the F distribution. So you will just attach it and you will get that particular value of that distribution, right? So now we have one interesting thing for you. So hypothesis testing in R. So everywhere generally we are using hypothesis testing, right? So means just these are the basic things. I have not put any theoretical thing here because this is required to know for your hypothesis testing. That's why I just put it, jot down these 4 points. So an overall model and related assumptions are made. So the most common being observation following a normal distribution, right? The null hypothesis, as you know, this is means denoted as H0, and the alternative hypothesis either HA or H1, right? Hypotheses are specified. Usually the null species has a particular value of a parameter. I will show you one example that is good for you actually. So generally we are going to calculate the p-value, and based on the p-value, so we have to either fail to reject the null hypothesis or we reject the null hypothesis, right? So that means we have to move with the data. So I will show you. So this is the basic T test. I hope you know this theory, right? So I am just checking with the example. Look, this is the practical example for you. Suppose a grocery store sells, they are selling 60-gram packets of a crisp chips, right? Nowadays so many chips companies are there. So a random sample of 9 packets was taken and weighted. The weight in grams are stored in the data frame. Say I have put it in the data frame. So this is the crisp. I put the variable name chips underscore crisp because this is the packet of the crisp chips, and I put it the data dot frame, and then the weight, all the weights I have put it. The company that makes the crisp chips claim that they have the average weight of a packet is at least 60 grams. They are offering means 10 rupees में आपको 60 gram मिल जाएगा. So how will you calculate whether they are really means they are really offering the same what they are claiming or not? For that, how you will put the mathematics in the practical field, right? So we will assume the weight of the chips in a packet is normally distributed and use a 0.05 label. That means significant level that we are setting it significance to test the company's claim, right? So to test it, we have to check whether mu, our H0 null hypothesis, mu is greater than or equal, because they have told at least 60 gram, versus our alternative hypothesis, that is H1, that is mu less than 16, right? And our test statistic is this, right? T distribution. So we have the X bar. Earlier days, usually we are doing in this way. We have the X bar. We are calculating the means. We are calculating the standard deviation. We have the mu 0. We have the number 9 with us. Then this is the formula. With the help of that, we will get that minus 1.2. Under the null hypothesis, the test statistic is t distribution with n minus 1 degrees of freedom. Here n is 9, right? So if you put it in the formula, you will get it. So 0.132223336. Now we have the p-value of our test, which is greater than our significant level, right? So thus we fail to reject the null hypothesis, right? So this is the way how we will implement it. But nowadays we have, means even if you have the alternative process, so then one sample t-test. So with the help of that, you can check it with the help of just one line. That's it. That is t.test. X is equals to the chips underscore clips $weight, because you are going to test their weight. Their mu is 16. Alternative is C is less, and confidence level is 95, right? I have put it 0.05, right? That means our confidence level is 95%, right? So now we can easily calculate it, and thus from there we can conclude that the claim of the company, Clips Chips Company, that is true, right? That is true. So this is the way we can implement it. So if you go for the two-sided test, earlier you have the so many lines of code, but now just look at the last penultimate one, that you will get the name and you will get the result, right? So confidence level you can easily calculate, because as this is the two-sided, that's why alpha by 2, confidence level 0.05 we have put it for the single-sided. Here for the two-sided we have that alpha by 2, that's why 0.025, right? So now we can easily calculate the same with the help of this command. So now we are slowly moving towards the data mining thing. So now everywhere we are talking about data mining. So now we have the data-driven analysis to uncover otherwise unknown but useful pattern in a large data set, right? To discover the new knowledge and to develop predictive model. Because everywhere we are just trying to do the figuring out the model where our data is going to fit, right? And turning the data and information into the knowledge and one day power of wisdom in a timely manner, right? So application of machine learning, statistics, software engineering, everywhere you will get this particular data mining thing, and you have to discover the new knowledge, improve your business outcome, or you have to deliver the better tailored services, right? As per your company or as per your research need, right? So look, this is the simple code for linear regression with R. I just put it here for you. So for that, for anything in R, you have to just call that particular library. That library is mass library. I am fetching here. I am attaching the data set that R, and then LM means linear model 1, that I am creating one model Y on X, that is distance versus speed, right? So then I have the regression model, I have the LS fit. So then we can easily plot it. We can summarizing the linear model, right? Similarly, we can go for the histogram data. Galton data is very popular in our packages. So there also you can go for this. But here the main purpose of putting this particular code is the summary within bracket linear model. You know, in summary actually you will get such kind of things. Means it is not so easy to interpret. That's why I put it here for you, that what is the meaning of all those things. Means these are numbering as 1, 2, 3, 4, 5, 6 up to 10, right? So if statistic is there, R squared is there, residual standard error are there, significant level is there. So what does it mean? So I have mentioned everything here for you. I am not going in details, because this is for the computer science generally people. So still I have kept it here for you so that you should understand that one single star means this is low significance and 3-star means this is being some high significance, right? So what does it mean? Significance means 3-star indicates that it's unlikely that no relationship exists between the weights of the parents and height of their children, right? So this is the Galton data. Actually, they are talking about parents, height of the parents and height of their children, right? So these are, everything is there for you. Just go through it. So interpreting. Now, the main purpose is that the summary of this metric evaluation. So if you have the statistics with you, R-square statistics, what is the criteria to check? Means if R-squared is higher, that is better, right? Greater than some value, if that is there, that means your R-squared is going to work for you. Means adjusted R-square, this is higher is better, right? So T statistics, that should be greater than 1.96. Standard error closer to 0, better, right? AIC and BIC, lower the better. I will discuss about BIC, that is also included in some chemical packages. So that's why I have put it in my slide, BIC. So and Mellows CP, MAP. So mean absolute percentage error, lower is better. MSE, I hope you have heard about MSE, right? So min max accuracy, higher is better. So these are the criteria that we have to maintain, right? Whatever we are getting from our derivatives, so how to interpret that derivatives, how to interpret that output, that is very important, right? If you don't know how to interpret your result, then make no sense for you, right? Or it is not possible for you to justify your result. That's why, so you should know what is the meaning of which statistics, right? So now popular cluster data mining process means packages that those are available, algorithm also available inside the R. This is cluster analysis. I hope you have heard of K-means algorithm, association rule, linear LDA, logistic regression, decision tree, random forest, bootstrap stamp, neural network, support vector machine, everything or anything related to data mining algorithm. You think about it, you just bring that library into the environment and you just work on it, right? That is the main aim. So as I already told that why we are choosing R for computational chemistry, right? So because this is the nowadays the new term coined, that is data science, right? So that is everything about analyzing the data. So you have to analyze your data, how efficiently you can analyze your data, and with the help of R you can do it freely, right? So R has the most extensive suite of functionality available with R. Nothing else is in any longer even close, right? Statistics can be complex and traps away, right? So many tools in R to deliver insight. So last 2 points actually very important for you. So you may ask me that how to remember how to do all those things in R. This is very difficult, really difficult, right? And how I skill up, how to skill up in data analysis process with data mining, right? As a data analyst, how can I skill up my thing? So for these two, this is the answer, right? One is swirl, another one is rattle, right? What is swirl? So if you want to learn R in R environment, you have to install one package. This is swirl. I will show you that everything that is available inside swirl package so that you can gain your confidence by doing it hands-on, by doing it in your own computer, in your own environment, right? So that is available in swirl. So swirl is one packet I will show you. Another one is rattle. For data mining thing, anything and everything, you can do it in rattle. I will show you some outputs, some fabulous output that we can draw from through the rattle, right? So swirl, what is swirl? Swirl is a platform for learning and teaching statistics and R simultaneously and interactively, right? So the simple thing is that you have to just install that packages swirl, and then you just fetch the library swirl, and then you just start your environment with swirl, right? So this is lean heavily on exercising our students use of the R console. This is the callback mechanism, and this is proposed by the Hadley-Wakeman, right? And this slowly it becomes standard that if you want to learn R, you go to swirl in R, and then you just complete all the exercise that is available. That is interactive exercise available in R. It will show you something, and then it will ask you the similar thing in our environment. Fabulous, actually fabulous. You know, tell me any one single programming language which will offer you how to learn that programming language within that environment. Sorry. So but you will get that thing in Swirl, right? In R, you have the packages. You have the only package Swirl. You just installed it, and it will allow you to learn R in R, right? No need to go anywhere. That is the beauty of Swirl, right? And second one is Rattle. Rattle is built using R. Need to download and install R from Crane project, as I told, R Studio, and then you start up with Rattle with install.packages. And dependency obvious, you have to keep in mind that always you have to write dependency is equals to true, unless otherwise it will means when you write dependencies equals to true, it will fetch all the associate package which are required for running this particular Rattle in R Studio, right? So then you can start up the Rattle, and then you have to require the package are loaded as needed, right? So this is Rattle is used everywhere: health analytics, customer segmentation and marketing, fraud detection, government, anywhere you think about, it is used by all the major universities, right? And it is and will remain freely available. Okay. So now the practical session for you. So this is the practical for Rattle. So look here in the below quadrant, I have just typed Rattle, right? And it will automatically open this particular data miner for Rattle. Okay. So now it is available here. So now I am executing, I am fetching the file name. In the file name, I have the file weather.csv. I am just fetching it, and now I am the file format. I am trying to fetch that thing, and then I am doing all kind of analysis with my weather data. Look, this is the correlation of the weather data that is available in the CSV file. This is the dendrogram kind of thing that is available through Rattle. So this is another. So everything. So LDA discriminant coordinate, you will get it in with the help of Rattle. No need to go anywhere, right? So correlation cluster, that is also available in Rattle. So this is also a correlation cluster kind of thing for you. So I hope you know about OOB, ROC, receiver operating characteristics, and AUC, area under the curve. With the help of that, we can adjust that false alarm rate and hit rate, right? So for anything, so we have to calculate this ROC or AUC. So that is available with the help of Rattle. I have the data, so I just fetch that data, and then Rattle will do rest of the thing, right? So this is the environment. Here I have that everything with me. So I have the source file. I just bring that source file, and then I am just transforming it, clustering it, associating it, modeling it, evaluating it, logging it. Everything is possible with the help of Rattle, right? So this is the out of bag error rate, random forest. So that is the weather.csv file that is also available. So now this is one interesting package I should not miss. So this particular package, ggplot, you know, the general plotting and plotting with the help of ggplot. This is very very interesting package. If you put it your graphical thing under ggplot, you will get the graphics in a beautiful manner, right? Yeah, so look, here I am fetching the library ggplot2 after installing obvious. So I have installed .packages within bracket ggplot, and then I have the dependency is equals to true. So then I am fetching library ggplot2. Now I have the qplot. In the qplot, I am typing minimum temperature, maximum temperature, and I have the data with the .csv, right? So it will plot you like this. Some complex thing. Look, this is the humidity at 3 p.m., pressure at 3 p.m., color, what rain tomorrow, data, weather, it is going to give you, right? So this is, it is showing in the legend that rain tomorrow, no and yes, right? Based on the humidity and pressure, it will calculate it. So this is direction of the wind, pressure at 3 p.m. So what kind of geometry I am asking? I am asking jitter geometry. So it will plot it like that. Look, so nice graphics and with minimal effort. That is the main thing. In R, this is possible. So we have to do it, right? So this is my submission to all of you, that you just put R and RStudio in your machine and just try it out. Means this is very good software, and this is very lightweight software kind of thing, and it you will get, means you will learn it very quickly, right? This is the best thing you can do it after the class, right? So this is the qplot with again in ggplot. This is the qplot. You just put it. So for computational chemistry in your domain, so these are the main packages. What I found that these are the packages generally people use in computational chemistry. Either this is Bayesian interference, for that they are using Bayesian package. ChemPhix, that is the chemometrics and computational physics, clinical trial and clustering, differential equation, distribution. So this is medical imaging, machine learning, high performance computing. You think about, so all those packages are available in computational chemistry, right? Computational chemistry. So these are the two packages that we are going to discuss. This is one package is that ChemMine-R, another one is chemometric, right? So this is ChemMine-R. This is the chem informatics package for analyzing the drug-like small molecule data in R. It is designed and implemented by these three personnel. This is the latest version, content function for efficient processing for large number of molecules, and physiochemical and structural property predictions. That is also available here. And you will get the structural similarity searching, classification, clustering of compound libraries with a wide spectrum of algorithms. Everything is free, right? So it offers visualization function for compound clustering result and chemical structure. And second one is chemometric. This is the multivariate statistical analysis tool for chemical data. This is implemented by these two fellows, so Bharmuja and Filmoza. So this is designed especially for the multivariate analysis of chemical data, and content function mostly for the regression, classification, and model evaluation. So first we will discuss about chemometrics and then ChemMine-R. Okay. So this is the chemometrics focus point, the idea of principal component analysis. You know, principal component analysis, the main thing is that to transform the original variable to a smaller set of latent variable, right? Principal component, with the aim to maximize the explained variance of the data. Okay. So here the no need to work with the n number of data points. You have to first check it out. What are the variables? What are the points that are very much required for your that particular analysis? You have to fetch only those variables, and after that you have to perform your all machine learning algorithm, right? Since the new variables are uncorrelated, we get rid of the multicollinearity, and then we can use the respective chemometrics functions that is demonstrated with the help of practical data example. I will show you. Right. So the process of finding the optimal variable to use for the model or an adequate transformation of the data and the optimal values for the model coefficient is called the calibration of a regression model. Okay. So a method that unlike OLS, or OLS, I hope you know that ordinary least square regression. So that is does not require uncorrelated variables or normal distribution of the residual. Is principal component regression, where not the original variables are used for explanation of the dependent variable, but the principal component. We have to take only the principal component to calculate our principal component regression, right? The components are chosen in a way to maximize the prediction performance of the regression model. So apart from the above, this package is capable of performing classification methods like k-nearest neighbor and classification T, or an artificial intelligence, artificial neural network for your calculation, right? So chemometrics package is available, right? So if you perform some tasks, so here I have discussed that BIC, so Bayesian information criteria for a linear model will normally distributed residual. The BIC is a function of the sum of the square of the model residual and given as this, right? So since the RSS means residual sum of square, don't think it otherwise, right? So RSS decreases with increasing A, right? So the BIC contained a penalty term depending on that particular number. So there is no meaning of absolute BIC because it describes the loss of information compared to an exact model. Thus, the lower the BIC value, the closer to reality in the model and better in its performance, right? That's why we choose the variable that causes the model with lowest BIC value. Okay. So this is one nice example for you all. Just go through it, then I will explain it to you all. So here, what I am trying to do, I am first trying to install the chemometrics package and then fetching the library. Now another package I am going to install, GCLAS, fetching the library of GCLAS. From there, from this package GCLAS, I am fetching the data of the wine data set. You know, in the wine, you have to calculate so many parameters, right? And this is all chemical parameters that you have to check. And if you have the chemometrics package with you, so obviously you will get it. Like I am scaling it, I am putting the thing, and I am trying to find out the PCA with the help of cross validation. CV means PCA CV, that means principal component analysis cross validation of X. There I will get the 5 main component, right? So there, with the help of the nipples, I hope this is the nipple is this one algorithm, that is nonlinear iterative partial least square algorithm, that is invented by H. Wold in 1966. So with the help of nipples algorithm, if you try to put it, so you will get after 2 or 3 iterations, that may be the suboptimal solution for you. You will reach the suboptimal solution. That's why it is required to mention iteration number. At least 160 iteration you should go ahead, and then you just explain it your variables, right? So with the help of that, we can do it. And this is the library. And after doing it with principal component analysis, we can do the same thing with the help of robust principal component analysis based on projection pursuit, right? And then we'll get this particular result. So here I have the near inference. You know that here I am asking all the variables. These variables are related to all your chemical data thing. So if I try to calculate, and if I try to put plotting it and model designing the model, then I will get like this. So I am designing the final model, all those things, and here I have that per MA row. That means I am trying to draw one row with 2 columns, right? That's why C is combining 1 row with 2 columns, and then I am prediction from repeated CV and measuring x-axis, y-axis, and last one is the PCR, that is principal component regression, right? So that we can also do it with the help of with the help of chemometrics packages, right? So this is the PCR kind of thing. We will get that all those 5 explain and variants, and these are the main 5 variables available in your data, and from there you can score distance, you can orthogonal distance that you can calculate, right? So from your score distance and all those things, you will get the error, right? So AB line we have done. This is the outlier detection. I hope you have heard about outlier detection. Outlier for one particular model, data treated as an outlier in one particular model may not be outlier in another model, right? That is also important. So we have to means we have to take care and very carefully select our data during analysis, unless otherwise it may gives us problem, right? We may unnecessarily remove the data which is important, or data points which are important for other analysis. We may remove it, right? During outlier removal, right? So such kind of thing. So if I write it down, so this is the code I am achieving the precision. So converging, I am trying to converging. That's why I have put it that after 5 iteration, this is stopped that particular. That's why we have to mention in the line number 9. I have mentioned iteration number is 160, right? Line number 9. Okay. So this is the number of component. So BIC during stepwise regression, right? Predictions, standard error predictions, AB line, everything is there, right? So next package is ChemMineR. So I have time, right? 10 minutes at least, Anurag?
Yes, sir, please.
Okay, thank you. So ChemMineR, this is another cheminformatics package for analyzing drug-like small molecule data in R. Its latest version content function for efficient processing of large number of small molecules, physiochemical and structural property prediction, structural similarity searching, and clustering of compound libraries with a wide spectrum of algorithm, right? So it also offers visualization function for compound clustering result and chemical structure. That is important. So everybody, they are always talking about that I am trying to do the computational chemistry thing, but how will I get the chemical structure in R? Is it possible? Very much possible. For that we have the ChemMineR, right? So the integration of cheminformatics tools with the R programming environment has many advantages, such as easy access to a wide spectrum of statistical method, machine learning algorithm, and graphics utility. That is the main purpose, to integrate it with R, right? So we have the improved SMILE in the new ChemMineR. I hope you all know about HDI and SMILE. These are all chemical terms, right? So PubChem and PubMed and ChemMed, right? These two databases are there. So they are SMILE mill simplified molecular input line entry system, support via the SMI set object class and import export function, integration of the subset of OpenBabel. OpenBabel, I will show you how to incorporate the OpenBabel with the via new ChemMineOB add-on package. Streaming functionality is also possible. So for processing millions of molecules on a laptop, think about mismatch tolerant maximum common substructure, that is MCS. Such algorithm that is also available, and fast and memory efficient fingerprint search support using atom pair of PubChem fingerprints, right? So these all those features are available with ChemMineR. Okay. So this is the actual integrated structure of the ChemMineR. So in ChemMineR packages, you can easily call EIR packages, EI algorithm, and flexible MCS algorithm, bioassay support, ChemMineOB, OpenBabel functionality, and it will give you such kind of binning clustering, hierarchical clustering, multi-dimensional scaling, everything. You can get it with the help of ChemMineR. And it can integrate with all the other packages associated in computational chemistry. That is the good thing about, right? So you will get this kind of atom frequency there. So So this is the compound output. Look how beautiful it is, right? So this is the package, you will get it here. So with the help of this ChemMine, you can generate such kind of compound structure inside your R environment. I will show you. So this is the compound 3 and 4. I have worked with 4 compound. So even if you want to visualize it on the web, that is also possible. Yesterday evening, actually, look, 24/11/2020, job start time. So this is the job that I am planning to visualize the result of all these particular identifier, that unique identifier that is available in the PubMed or ChemMed. So that identifier and the structure of that particular against that identifier. Okay. So these are the books available. You can, these are, most of them are freely available. Some books available in R. So this is for self-development. You can go ahead with this IBM cluster, and this is the cloud IBM providing the facility, labs.cognitiveplus.ai. Here you may create your own account and you can submit your job there. So this is very much freely available kind of thing, right, for you. So now I am planning to show you that practical. So first, I will show you this one. So first thing first, I hope you know how to open the RStudio, and then you have to set the working directory. That is very much important, right? So here I have that source file location, right? So this is that, means how you will go there. This is my file, source file location. Look, this is the place. So from here you can choose alternative place as per
Excuse
your
me,
wish,
sir.
right? Yes, please.
You have to do a new share. You stop the previous share so that.
To share it, okay. But this is, I have shared my whole screen actually.
No, it is not showing the whole screen.
Or it is not showing.
Yeah. You stop the previous share and you do the new share again.
Okay. Let me just check. Now this is working. No.
It is working now.
What you are getting right now?
Now
Slide.
it is working. Now it is working.
Slide or R interface, RStudio interface.
Right now slide is coming.
So now RStudio.
Now RStudio is coming.
Oh, great. So now, so here from this right hand side corner, go to the directory. From there, I have to choose my working directory. This is very much required. So this is the, in the desktop, I have the chemistry talk. So there I have everything. That's why I am opening. So look, as I open this particular place, chemistry talk, it is showing set WD C user ISM IIIF desktop chemistry talk, right? So now here I have all the data set bdims.art data. So I am loading that data. If you not set your working directory, and then if you try to load your data, you will get error message, right? So you have to load your data, and then the M dime and the F dimes means male and female, and then I have the histogram. So I am just executing this for you. So I have already run that. How you will run the code? So you have to save it as an R. This is the project. Save as. This is the save as. It is, I am already in my chemistry talk. So this is means say this is the programming 3. Programming 3 dot capital R. So this is the way to save it, right? So that's all. So now I am loading my data. So you just put it here, your cursor, and then you just run it. Okay. So I am running now. It is in the panel, in the second quadrant, you will get is load bdims.art data. Now I have the number 5 lines, number 5. then 6, then 7. Look, this is my initial histogram based on the female height dimension, and now I am imposing on it so male, right? So how you will impose it? You have to write this add is equals to true. So under one graphics, if I want to add it another graphics, I have to put this add is equals to true. Okay, and then I am circling, rounding it with the help of box, right? So this is the way. So look nice. And if you want you to export your graphics, this is the file, export, save as image or save as PDF. Even if you want to put it copy to clipboard, from there you can put it in Paint. Whatever you want to do, you can do it, right? No issue. And packages, inside packages, I am talking about install packages, right? So this is the place under packages you have the install button, right? So here you type it. I am typing Kim. So all the packages, this is in the repository CRAN. That's why all the packages available in the CRAN related to Kim. So that is available here. So you just choose it, and then you have to just tick this one, install dependency, right? So and then you have to click on this install. Look, you have to click on this install. Yeah, so it is working. Look, this is working. So if you you have to connect your machine through with internet, and then so now I have this particular chemical. How I will invoke that chemical? I have to just type it here. Look, this is in the search button, 4th quadrant, chemical, right? So chemical, first one. So this is not yet invoked into the environment. I have to just click it. So automatically the program, the corresponding command that is executed here in the console panel, that is library chemical, right? So install.packages with dependency, and then I am calling the chemical, right? So you want to know about chemical, even I don't know. The description is calibration function for analytical chemistry. You want to know more, you just click on this chemical, right? So it will show you all the description, documentation for the package chemical, what are the function available, what are the help pages available, and then from there you can put it all the descriptions. Okay, that's all. So this is the beauty of this particular environment, R&R Studio. So so this is the viewer where you will plots, where you will get all your graphics, right? This is the place files, from where you can set your files. How you will set it? Here from the session, set working directory, either your source file location. Source file location means left top corner, or file pan location, that means right below corner, right? So this one is the source file location, file pan location, or even you can choose your directory from here. Okay. So this is the first example. Second one, so chemometric, right? Let me just check it out. So as I told, first I have to go for the installed packages, as I have already installed these packages for checking purpose and generated the output. So I am just doing from the second line. Okay. So library chemometrics, installed packages not required because already I have installed that. So again, library G class, and then I am fetching the data, right? And I am just putting it in the column type, in the variable, assigning the value. Now I am calculating the PCA CV. Look, this is the plot immediately generated here in the 4th quadrant, right? So this is the iteration, this is the calculation without iteration. So now we are putting with iteration, right? It will take some time, right? So now I am calculating the residue. Look, these are the important explained variance, and these are the important variables that I have to work with. This is the diagonal power plot. So this is the PCAPP, as I told, grading, again calculating, right? So from that, we will get the outlier. We have to calculate all the outlier points that I have already put it. Now, here near inference data set. So here also I am fetching the data. I am putting it X and Y axis, then attaching the X, Y, glucose. I am just with the help of that data frame, I am fetching that glucose details, and I am just calculating the linear regression model, right? This is also a type, right? So no need to write the dependency. You just Y on X, you just put the Y, it will automatically take that particular X from that data set, okay? And this is the plotting. Okay, so length is differ, okay, no issue. So I am getting the steps, seconds. So model size, look, this is the one. Here what I have to put, this is, look, this is the two column kind of thing, right? So what I have to put, I have to put these things here. And I have to make it 1 1, right? 1 1. And if I now run again the plot, look, this is in the whole space, right? This is 1 by 1, unless previously it was 1 by 2, right? This is the final model. So step calculation with the help of BIC, right? This is again, I have to do. Here I am generating 2 data points for them. AB line I am planning to draw. So this is the AB line. Now PCR with R, that is also available. This is the code for PCR. It will take time because number of iterations, yeah, this is 100, right? So it will generate 100 numbers here. So look, this is the right panel. You will get the prediction from repeated thing, standard error, a predicted value, means everything you will get it. And so nicely, that is the main thing. Without any much writing of code, you will get all your graphics and all your visualization thing in R. So easy, right? You just go through it, you get it. And from there, OPT PCR, you will get the point. Here the data point we can easily calculate that we will get after the iteration, it will show you most probably 30 or 31 point number. That is the optimal point that we have to choose. So then according to that, maybe we have all the graphics is there, right? This is 75. So 99, 100. Now this is close. Yes, right? So now if I just press this particular command, run this command, look, I am getting the distribution of all those things. From there, I will get the final value. Final value most probably associated with these. Yeah. So look, this is the point. This is the highest point. This is at 31, right? So we can easily identify that particular means variable, that component for which we are getting that particular result. Okay. So I am not going through the last 3 lines. You just check it out. So the next example is in ChemMine. This is very interesting, you know. So this is here, this is the bioconductor. As I told you, that BioC manager that is already available with me. If I go to the package and if I check it out here, BioC, look, BioC manager is available with me, right? So BioC installed packages, I have not mentioned. So BioC manager is not required. I have the ChemMine R with me, right? ChemMine R. ChemMine R with me, and the library already I have fetched it. So library ChemMine R is not required. Look here, this is the interesting one. If you run this particular command, library within the bracket help is equals to ChemMine R, it will list all function and classes. No need to go anywhere. Look, this is the details about your ChemMine R. You will get everything related to ChemMine R, right? So just go through it. That's why I just put it here. And now you know the this SDF data format, that is PubMed or PubChem structured data file format. If you just call that data, and then I am putting the in a variable. So I am returning the summary of that. So it is showing that an instance of SDF set with 100 molecules, right? So here I am subsetting it with four molecules. So this is the details of that, how it store it here. So this is the header, molecule name, source, count lines, and you will get the atom blocks, you will get the data blocks, you will get the bond blocks, you will get the data blocks, right? So this is that SDF list, return the complete content of many SDF. Even if you want to fetch it from your any website, the SDF format, this is the command. With the help of that, you can easily fetch this particular thing, right? So Girke, he is the T. Girke, he is actually the inventor of this particular package, one of the inventor. From his website, if you want to fetch any structured data, so you can fetch it, or any from any database. If you want to fetch any structured data format, you can fetch it, and then again, if SDF set, and then again you have to perform all these things, right? SDF sample, store it, and then you just put it, you will get it, right? So here I have the header. Header will give you the top few things about that particular data set. Atom block, if you want, this is my atom block. So I am specifying more atom blocks, minimizing it. So I am getting this. Bond block similarly. So bond block, specifying bond block, data block. This is my data in the PubChem coordinate type. This is everything as in PubChem. So I am putting it the compound ID and keeping it unique compound ID, right? So These are the compound ID, unique, and then converting the data block and in the HDF set to a matrix, right? Because ultimately you have to put your data in the matrix. I am putting the num characters, slicing the numeric matrix and character matrix. This is the atom frequency, the graphics that I have already shown you. This is the graphics, will generate that graphics for you. So look, even if you are trying to find anything through grep, I hope you know in Linux grep global regular expression, search it and print it, right? So that is also possible. Look, this is also possible. So you want to export your file HDF set to HD file, that is also possible. So here I am just dev off actually stopping my basic graphics. It is taking this particular R graphics, right? So I am plotting it. Look, this is the thing. If you zoom it, you will get the whole thing, right? So beautiful, right? So if you want to put it structuring the similarity, now I am trying to do it, visualizing it in the with the help of web. Look, this is the ChemMine website where it will show you, right? That job start time. These are all the identifier. It will automatically bring you in this particular website. Okay. And then if you go for the structure similarity, searching and clustering, that is also possible. So I am fetching the data, I am comparing, searching, and then clustering, smiling inputs, full form of the SMILE, I hope you know, simplified molecular input line entry system. So CMP cluster. Now I am trying to fetch this one. I will show you the ring also. This is how to write in SMI set. So this is the accessor function that we generally create to fetch the data. Now this one is important, Open Babel format. As I told you, I have already installed through GitHub. I hope you have heard about GitHub. GitHub is a worldwide repository of the data set and the programming thing. So from the Girke lab, I am just fetching this particular, because this OB, this package is not standard package and this is not available inside the package. If I type ChemMine OB, nothing is there, right? So from the CAN, it is not possible to install it. So other way to install it, so you will go for installed_GitHub. For running this particular command, installed_GitHub, you should have the remote package in your machine, remotes. Look, this remote package is required. So as I am not running this thing right now, so that's why I am not enabling the remote. So I have the library, just bring that library in the environment, convert an HDF set container to the SMILE character string. I am again fetching the data. This is the SMILE. So this is the one molecule. I am converting to HDF. So HDF to SMILE, SMILE to HDF, that is very much possible, right? So now if you want to create some database, say nowadays database handling is very much crucial. How will you put your data inside the database? That is also possible in our environment, right? So I am fetching the data HDF sample, and then I am trying to create some difference, say KM. So I am writing Anurag Sunda, say astest.db, right? So if I put it astest.db, so this is also possible. I am creating this connection. Look, creating the DB. Okay, so database created. Now I am fetching the data into that, putting the data inside. So it is taking some time. So I am list the feature in the database. Look, so I am listing the feature here. We have these two features, right? The one is aromatic, another one is ring. I hope these are popularly, means you know it, right? In your chemistry, these are the popular two things, features. Either this is the aromatic feature or having the ring feature, right? So you can get it. I don't know much about it because I am only aware about the R environment, right? So number of rings less than one, how many are there? So it is founding three such kind of structures are available, right? So less than two, this is 10. So all ID I am trying to fetch 100, right? Because we have the 100 molecules, so that is already there. And then, so now this is the molecular property function, physiochemical descriptor. That is also possible to fetch it here. Look, I am trying to do the box plot. Why this is coming? What I have to do? Tell me. So I have to do the same command. I have to write this command, right? I have to write this one. Okay. So now if I run this box plot, look, this is the atom frequency that I am getting. Okay. So property, if you are planning to fetch the property, the symbol, atomic weight, group, periodic table, everything, you will get it, right? So these are the things available. So enumerating the functional group. So these are the four compound that I have already, yes. So if I am planning to do it, everything I will get it here. And now, look, I have all kind of bonds. I have the charge, everything I can visualize as in the database, right? Index, look how beautiful. So everything is available. This is the compound 2, this is the compound 3, compound 4, right? Even if you want the compound name instead of that ring, you can do it with the help of this. And good thing about all those things that you have that all the graphics available stored here, right? Unless you clear it, it will be remain here till you are in the session. Once you close the session, then those plots are not available. Again, you have to run the command. Okay.
Just please tell export of these graphs also if possible.
Huh?
Export of these graphs.
Yeah, this is the export, save as image.
Okay.
If you want to zoom it, zoom. Look how beautiful, right? Excellent, actually. So that is my submission to all of you. So if you, this is the zoom. If you want to export it, save it as image, you just put the directory name where you want to put. I am putting it in the chemistry talk. So I am typing CM4, right? This one, compound 4, CMP4 1 dot JPG. If this is JPG format, so I am planning to do it. So just take it. This is the directory. So here you have to write the file name. Format is available if you want in TIAA format, BMP format, SVG format, EPS. For LaTeX, you need EPS format. You just put it and then you will get it, right? So if I going to save it in as a JPEG, no need to write this JPG. So then it will save your. And if you want to check view plot after saving, you just tick this below one, right? And then save it. Save. Now you will get the image even. Look, this is the image, right? You will get it. So yeah, even if in as a PDF, you can write down the same in the A4 landscape, whatever the manner you want it, you will get it. In the PDF, you will get it, right? So beautiful. You are getting this PDF, Anurag?
Yes, sir. Yes, sir.
Okay. So this is there in my folder. If I check it out, I will get it, that particular CMP4 PDF. Look, CMP41 PDF, right?
Yes, sir.
Storing here. So that's all from my side, I hope. So this is the not the end, journey begins for all of you. So this is the Vince Lombardi. Perfection is not attainable, but if we chase perfection, we can catch excellence. So try it out. Thank you all for your attention. Thanks.
Thank you, sir. Thank you very much for your wonderful lecture. And I would like to mention to the students that it is always a tedious task once you generate the data from a particular software tool or any chemistry model. You always face difficulty to analyze that data.
Right.
So, sir has shown a very beautiful options here in the R Studio, by which you can analyze and you can plot the things the way you would like to look at it. I would like to give one example here that let's say you have a 200 amino acid sequence and you may have a repetition of a particular valine or some lysine amino acid, and you sometime you would like to exclude it, sometime you would like to include it in your analysis. If you have to do in the programming, you have to do it again and again. You have to write down manually. You have to identify and so on. But using tools, ChemMine, of course, it is very useful. But when you do it in a other interface, you always face a lot of problem and challenges to identify or sort out the problems related to that. But I am very much thankful that Koushik Mondal sir has shown us the use of Python R, where R is helping us to get everything at one place. And once you have your proper analysis, whatever you would like to have, you can export it immediately. So that is the beauty of this particular program, which I would like to mention to all the participants and students here. And thank you,
I
sir.
don't
Thank you
know
for.
much about chemistry, sorry.
Yeah, no problem.
Just my basic intention is to just to show you that you can do anything and everything in this particular computational environment.
Yeah, yes,
Just
sir.
use
Yes,
it.
yes, sir.
Yeah.
Thank you very much. I express my sincere thank to you on behalf of JC Bose University of Science and Technology that you gave your important time, valuable time to us. You accepted invitation and you delivered a wonderful lecture for all of us and motivated all of us to look at these Python R and R based packages, which will certainly help us to do better in our analysis part. Thank you, sir. Thank you very much.
Thank you all. Thank you for your presence. Thank you.
Thank you, sir.